In this video, we're going to do a quick introduction to Cis Trans Isomerization. In an sp3 hybridized carbon, which has single bonds, you have freedom of rotation. That means if you were to build a model of ethane, you could rotate those hydrogens around. However, in ethene, which has sp2 hybridized carbons, those hydrogens are now locked in place, and you cannot rotate this hydrogen to where this hydrogen is. If you're having trouble understanding this concept, you might want to build a model. First, build a model of ethane, and you can see how it can rotate around and those hydrogens can move about. And then build a model of ethene. And these are models of ethane drawn here using two different molecular model kits. You can see that there's no way you can rotate this hydrogen and put it in the place of this one. So if we have a carbon-carbon double bond, we can't do any rotation. These groups are locked in place. This means that you can potentially have what we call Cis Trans Isomerization. For example, if I asked you to draw out 1,2-dichloroethene, there are two possible ways you can draw this molecule. You can put the two chlorines on one side, or you can put one on each side. However, you cannot take this molecule here and rotate it to get to this molecule here on the right. Because that carbon-carbon double bond locks those groups in place, we have what we call Cis Trans Isomers. The cis example is over here on the left. Cis then means same side. And you can see that the two chlorine groups are on the same side of the double bond. Trans then means opposite sides. And in the trans example here, you can see that the chlorines are on opposite sides of the double bond. Cis trans isomers are possible whenever you have a hydrogen attached to each carbon, and the other groups attached to the carbons are different. Let's say, for example, we had 3 chlorines. Then in this case, you can see that no cis trans isomers are possible. If the chlorine moves down here, we just have the same molecule. In Chapter B, we're going to practice naming these molecules, so you get a lot more practice identifying cis and trans isomers.